Hello, dear student. This is me again, Mr. Ahmed Karim, at the private Zhyar and the basic school. So we are here again to study and explain another subject in mathematics for grade 9, and it is real numbers. Before we discuss or explain the main subject, I want to give you a real example. Okay, so let's say we have a family. Okay, if I ask any one of you about the family members, all of you are going to say the family members are father and mother, and also we have brother, and also you can say sister. This is the family member. This is not our subject, but I want to explain it because it is related to the subject. Okay, so real numbers, before explaining, we have to know the other sets of the numbers. The first set is natural numbers that includes 1, 2, 3, 4, 5, 6, and also the other numbers. So we use natural numbers in our daily life, like for example the number of pages when you want to buy something. Let's say you go to a store to buy, let's say, some stuff for yourself, then we use natural numbers. For example, let's say 2 apples, let's say 3 banana, and this stuff. Then the next set is whole numbers. We have whole numbers. Whole number is natural number, but one number is added, it is 0. So you have to be careful. 0 is not included here. 0 is not included in natural number. You have to be careful. If you have 0, so 0 included in whole numbers. So we have 0, 1, 2, 3. If you compare them, the both sets, we have 1, 2, 3, and here we have 1, 2, 3, and so on. But the only difference is we have 0 in the whole numbers. And the next set is integers. For the integer numbers, we have 0, and also in the right side we have positive numbers 1, 2, 3, and so on. In the left side, left hand, we have negative numbers. If you draw a line, the integer number line, you can see that 0 is the center of the line. Okay, in the right side of 0 we have positive numbers. In the left side of 0 we have negative numbers. Then the next set is rational numbers. The definition of rational number, it says it is any number that can be written as the a over b, but in a condition b does not equal to 0. b does not equal to 0. So any number, for example, let's say 2 over 3. It is a number that can be written in a form a over b. So 2 over 3. Or you can say negative 5 over 7. Or let's say 10 over 99. All of them are rational numbers. But there is one important point you have to be careful. Maybe ask that question: what if the denominator is 0? If you remember, in the previous classes we have explained that the top part of the fraction is numerator. It is numerator. And the bottom part is denominator. Okay? So by the definition, the denominator of a fraction cannot be 0. For example, let's say 3 over 0. Maybe ask that question: what if we have a number over 0? So it is undefined. Or you can say it is unreal. So it is undefined or it is and real or not real. Then the next set, and this is the same note that we explained. If the denominator is 0, okay, it is undefined. Denominator cannot be 0. So next set of the number is irrational number. There are several definitions for irrational numbers. One of them say, let's say, it's a number cannot be written as a over b. Okay. For rational numbers, we said that we can write it as a over b. But for irrational, we said that we cannot write as a over b. Or we can simplify that definition to, let's say, make you understand. You can say the irrational numbers are the square root of non-perfect squares. What does it mean? If you remember, we said that we have perfect squares like 1, 4, 9, 16, 25, 36, okay, 49, 64, and so on. They are perfect square. For irrational, it says the square root for non-perfect square. It means with all these numbers, except these numbers, okay, the rest of them are irrational. For example, let's say we have the square root of 3. Because 3 is not perfect square, that's why the square root of 3 it's going to be irrational number. For example, let's say we have the square root of 10. Because 10 is not perfect square, that's why the square root of 10 is going to be irrational. And so on for the rest of the examples. But guys, be careful with 8. Sometimes students are going to say 8 is a perfect square. Be careful, 8 is not perfect square because 8 comes from 2 times 4 or 4 times 2. So it's not perfect square. That's why the square root of 8, it is irrational. And the last set of number that we have is real number. If you remember, in the beginning of the class, I gave you an example about family. Okay, we said that family includes, this is family, and we have father, okay, mother, brother, and sister. So family is the big picture, is the big graph, and so on, for real number is the big family. All of them, let's say this is the real number, and the rest of the numbers are included in real number. For example, irrational, integers, natural numbers, and rational numbers. All of them are included in real numbers. So the big family, the big picture is real number. We can say, for example, 2 over 3, it is rational number, and it is real number as well. Okay, for example, the square root of 3 is irrational, and also it is real. Let's say number 2 is natural number, it is integer, it is rational, and also you can say it is real. So real numbers, or real number set, it is the big family, the big graph. So there is a very important note you have to be careful, and we need it for the rest of the lesson. It is the square root of negative numbers is not real or are not real. For example, let's say we have the square root of negative 9. Okay, the square root of negative 9. Because we have square root and also we have a negative number, that's why this number is not real. This number is not real. Also, let's say we have the square root of negative 10. because we have the square root of a negative number, because we have the square root of a negative number, that's why this number is not real. Okay, so again, I'm going to repeat it again. The square root of negative numbers, the square root of negative numbers is not real or are not real. But sometimes students are going to mix the subject. For example, we have this example, negative, let's say, square root of, say, 16. Okay? Maybe you mix this number with the other one and you say, because you have negative square root, that's why it is not real. Maybe say that. It's not real. But be careful. Be careful. Do not make that big mistake. This number is going to be, this is going to be negative 4. Okay? The negative is not inside the square root. Okay? It's not inside the square root. It must be inside it, not outside. We don't care about the outside of the square root. If you do not have it, let's say, inside the square root, so it's okay. So be careful. This number is not, let's say, you are going to say it's not real. Be careful. It is real. It is real. Okay. So we have some Nishtimani questions. This is the picture that shows the set of numbers. You can see the real number is the big one. Okay. Then we have inside real number we have irrational numbers, rational numbers, and also we have whole numbers and natural numbers. So we have some Nishtimani questions we are going to solve together. Okay, so the first, sorry, this is an example. The first example says, write all names that apply each number. You have to remember the names. I'm going to write down the names there. So we have natural number, we have integer, we have rational, and also we have irrational, and finally we had real number. Then it says write all the names that apply each number. The first one, we have the square root of 3. Square root of 3. Directly you have to think about the note that I gave to you. The square root of non-perfect. 3 is not perfect square and it has square root. That's why we are going to say it is irrational. Then we can say it is real because we said that real number is the big family, is the big circle that you can say it is real. So example B, we have negative 52.28. And also because it's a decimal number, it's a decimal, so we can say it is rational and also it is real. Example C, if you look at example C, is not like the previous one. For example, we have 16/4. So right now we cannot decide about that example because it's not simplified. First step, you have to simplify it. Then we decide is it real, integer, rational, or any of them. So let's simplify it. You know that the square root of 16 is 4. Write down 4 as it is. 4 divided by 4 is equal 1. So right now we have 1. Be careful. This expression, okay, after we simplified, we got 1. So what can you say about 1? It is real, and it is integer, it is rational, and also it is real. But you cannot say it's irrational. It's all of them except irrational because 1 is a perfect square, and also it is natural, integer, rational, also real. Let's see what do we have in the example E and also example F. Example F, again, it's not simplified. We have square root of 4 and there's negative in front of it and it's over 3. So we have to simplify it because it's not simplified. So the square root of 4 is 2, but do not forget that we have a negative in front of it. It's 2. Then write down 3 as it is. Okay, so we have negative 2 over 3. Negative 2 over 3, it is rational. Why? Because it is in the form a over b, and also we can say it is real. And the last example is 81 and the square root over negative 3. Again, we have to simplify it. You know that the square root of 81 is 9, okay, divided by negative 3. So 9 divided by negative 3 is equal negative 3, because positive divided by negative is negative. 9 divided by 3 is 3. So what can we say about negative 3? It is integer, it is rational, and also it is real. Okay? So, but students, you have to be careful. Maybe you are going to say negative 3. Okay, why it is rational? It's not on, let's say, in the form of a over b. Maybe I ask that question. For example, let's say we have the negative 3 or 2 or 1, or let's say single numbers. Maybe ask that question. Why are they rational? While we said that rational numbers are numbers that can be written in the form a over b, but it's not a over b. So the answer is, if you remember previous classes, let's say grade 4, 5, 6, and we explained that each number, or let's say every number, have denominator 1. Each of them have or has denominator 1. You can see that it is in the form a over b. That's why they are rational. Okay. Then example 2 is different from the previous example. If you remember, the first example says or said write all the names. Okay. For example, if you have a number, any name that apply for the number, you are going to write it. But in this second example here, it says state. It tells you state or write. Each number is rational, irrational, or not real. So we have only 3 choices. This is 1, 2, 3. We don't have natural or let's say real. It says write rational, irrational, or not real. So the first one, this is example G, the square root of 15. Is 15 perfect square? Of course not. Because it has a square root, it means we have a rational number. As we explained before, the square root of non-perfect squares are irrational. Then example H. Example H says 3 over 0. 3 over 0. The denominator is 0. That's why it is not real, because the denominator is 0. It's okay if numerator is 0. If you have, let's say, 0 over 3, it's equals 0. It's okay. It's going to be, let's say, real number and natural number, this stuff. But if the denominator, we have problem with denominator. Denominator cannot be 0, okay? But if the numerator is 0, it's quite okay. Then we have example I. It says the square root of negative 13. Directly, when you see a negative inside the square root, it's going to be not real. Okay. Let's check the other examples. We have example G. I think the letter is different. I repeat G. So we have to simplify it. Then we decide which one is it. So we have the square root of -8 times -2. Because we have a bracket here, we have a bracket between these two numbers, it means we multiply them. Negative times negative is positive. Even if you don't write the positive, it's okay. 8 times 2 is 16. So we have the square root of 16 and it's equal 4. So 4 is a rational number because we said that it has denominator 1. And also example I, we have the square root of 1/9. Okay, how can we simplify it? Again, if you remember in the previous lessons, we said that if you have a square root for a fraction, we can give or distribute the square root for the numerator and for the denominator. So we can write the square root of 1 and the square root of 9. Okay, so it's easy to find the square root of 1 is 1 and the square root of 9 is 3. As you see, we got 1/3, so it is rational number. Okay, so finally we reached Nishtimani questions. The first question is the negative square root of -13 is a number which is what? Rational, irrational, not real, or natural. So because we have negative square root, the square root of a negative number, so it's going to be it is not real because we have a square root of a negative number. So then the next question is, one of these numbers is not real. Again, directly we focus on the number that has negative number under the square root. So this is D. Then question 3, it says which number is not real? Again, we are looking for not real. When it talks about not real, it means square root has negative number. So which one has a square root with negative number? It is A, because inside the square root there is a negative number. And question 4, it says which number is irrational? Which number is irrational? So if you remember the definition of irrational, we said that irrational number is the square root of not perfect squares. Okay, let's check it. This one is decimal number, 0.13. It is 13/100. It is rational. Okay, the square root of 149, also the square root of 121, it is 11, and this one is rational. So the only, let's say, choice that's left is B. So 149 is irrational. So the example 5, question 5, we have this one. We have to simplify it. The square root of 25 is 5. 5 plus -5 is equal 0. So it says which one does not describe this expression. After we explain and this, let's say, simplify that expression, we got 0. So which one does not describe 0? It is not natural. That's why natural does not describe 0, because we said 0 does not include here. It's included in whole numbers. And question 6, it says what is the square root of 3 is called as? It is because 3 is not perfect square, then it is going to be irrational. Question 7, which number is irrational? Again, it is D. All the questions are repeated. Which one, let's say, best description of -9 with square root? It is not real. And also question 9, it says, question 9, which number is irrational? Again, which it is 11, because this one's decimal number is a rational number. This one's going to be 3, and this is rational. It says negative square of 36, it's going to be -6. So which one's the best, let's say, description for or describes the negative square of 36? Integer, rational, real, or not real, or undefined. So it is A. And the final question, it says, for what value of x, let's say, the value of x minus 19 is real number. So I leave this question for you. So try to solve it, inshallah. So dear student, this is the end of our lesson. Hope you get benefit from me. Thank you so much.
گروپی لاس بۆ فۆتۆکۆپی و پەراوگا لە خزمەتی قوتابیانی خۆشەویستدایە. بۆ ئەوەی لە وەرزی نوێی خوێندن ماندوو نەبن، ئێمە هەموو پێداویستەکانی قوتابخانەمان بۆ بەردەست کردوون بە بەرزترین کوالێتی و باشترین مەواد. لای ئێمە هەموو جۆرە مەلزەمەیەک بە کوالێتیەکی بەرز و جوانترین شێواز دەست دەکەوێت. هەروەها هەموو پێداویستەکانی قوتابخانە بە هەرزانترین نرخ دەست دەکەوێت. لە فۆتۆکۆپی لاس چاپکردنی کتێب و بزنس کارت و وەسڵ بە کەمترین ماوە و جوانترین شێوە. هەروەها چاپکردنی فلێکس و لەزگە و تابلۆ و چاپکردنی نووسین لەسەر کوپ و تیشێرت بە بەرزترین کوالێتی. گەیاندنمان هەیە بۆ هەموو شار و شارۆچکەکانی کوردستان. بۆ دەستکەوتنی ئەم بەرهەمانە سەردانمان بکەن بەم ناونیشانە: هەولێر، دووسایدی بەحرکەی کۆن، بەرامبەر ئامادەی ژیاری نەحکومی. گروپی لاس بۆ فۆتۆکۆپی و پەراوگا.